Today we're going to talk about something new. We've been looking at volume of three-dimensional figures. So here's our learning target. As an IB learner, I can use the ATL skill of transfer thinking to calculate. We're going to be calculating. We're going to transfer our abilities to find the area of 2D figures to finding the surface area of 3D figures. So what we've been doing is finding the volume, but today we're going to focus on finding the surface area of those three-dimensional shapes. I'll know I've got it when I can find the surface area of rectangular prisms, cones, cylinders, and square-based pyramids. So practicing what we've been doing. So let's talk about surface area. So we've found the area of 2D figures before using those A equals formulas. Well, surface area of a 3D figure is the amount of material making up the outer surface of the figure. So area, like area of a square, we said was the side length squared. Surface area is when you have a three-dimensional figure and you're finding the area of each piece of it. So if you broke down a 3D figure into surfaces, we call this a net, and you found the area of each individual shape, together you'd find the surface area of the 3D figure. So just like we do with area, surface area is measured in units squared, or units squared. Remember, volume is units cubed, but anytime you see area, it's going to be squared because it's a two-dimensional measurement. So let's look at an example. So in this case, we have a box, a rectangular prism, and this is directly from your formula sheet. You have the volume formula and you have the surface area formula. This is the one we're focusing on today, so don't worry about volume. According to the formula sheet, our surface area is found by using this formula. Surface area equals 2 times length times width plus 2 times length times height plus 2 times width times height. So it's kind of a lengthy formula, but you have your calculator, you can plug it directly in there and then tell your calculator what value should be for length, width, and height. So just like with 2D figures, we can plug these in to find the surface area. You could also, if you wanted to, break down the shape into each surface, find the area of those, and then add them up. So for example, let's say we had this rectangular prism. So we have 7, 9, and 4 as our length, width, and height. And we could say either of them is length or width or height. It's just important that we have the 3 different measurements. If we were to flatten this box, like imagine you get an Amazon box and then you break it apart and flatten it so that you can recycle it, this is what we call a net. So this is looking at it flat, breaking it down. How many shapes, how many sides of the box are there? Well, if we were to count the box in the three-dimensional figure, we have a top, a bottom, so that's 2, a left and a right, that's 3, 4, and a front and a back, that's 5, 6. So notice when we flatten it, we should also have 6. 1, 2, 3, 4, 5, 6. And if we found the area of each of these faces, we would find the area of the whole figure. So if we went through and did that, we would get all these numbers and then we could add them all up. Whether we do that and break it down using a two-dimensional net or we just plug in the formula, we're going to get the same answer, which in this case is 254 units squared. Looking at this, you're going to see that just plugging into the formula is going to be a whole lot faster than trying to break down a figure, find each individual piece, and then add them all together. This is like a composite shape. We're just going to use the formula and let our calculator do the work. So real quick, we have been talking about volume in previous lessons, and today we're talking about surface area. So let's look at some examples of real life situations and determine whether it's talking about surface area or volume. So remember, surface area is covering something, and volume is like filling something. So if we're painting the walls of a room, are we talking about surface area or volume? That's going to be surface area. Filling a fish tank with water would be volume. Wrapping a gift with paper, so that's the outside, surface area. Stuffing a teddy bear, volume. The amount of carpet needed for stairs, so covering stairs, surface area. Filling a snow cone with ice, that's volume. The amount of fabric needed for a basket, so that's like covering a basket, we'll say it's surface area. The amount of air in a tire, that's filling up the tire with air, volume. And covering a structure with drywall, so covering it is surface area. So you can look for those keywords to determine whether it's a situation of surface area or volume. So let's actually try to find the surface area of some different shapes. So here's our figure. What kind of shape is this? This is a cylinder. So it's like a can, it's like a soup can. So on our formula sheet, there's the cylinder. And remember, we're finding the surface area. So we need to use the surface area formula. So I don't even care about the volume formula. I'm only using the surface area one. It's very important that you use the correct formula. So we always start out by writing the formula. 2 pi r squared plus 2 pi r h. Now, remember for pi, we always use 3.14, and r stands for radius, the center of the circle to the outside. It's halfway across. So they tell us that our radius is 7, and our height is the distance between the two circular bases. In this case, our height is 14. So let's plug in our values. So here's what our formula looks like when we plug in those values. 7 for r, and then 2 pi r h. And then we can plug this directly into our calculator. Another way you can do this is you can type this exactly into the calculator and then tell your calculator in the next line r equals 7 and in the next line h equals 14. Or you can type it in this way, either way. Let's see what we get. So we get a surface area of 923.16 square inches, or inches squared. That's our final answer for the surface area of that cylinder. Okay, how about this shape? What is this? This is a cone. Remember, it looks like a traffic cone or an ice cream cone, and we are finding the surface area. So of the two formulas, we don't need the volume formula, we need the surface area formula. We always start by writing the formula, and let's plug in what we know. We know that for pi, we always use 3.14. What are we going to use for the radius? The radius is from the center to the outer part, halfway across. Look at that. They told us that the radius is 6. So we'll do 6 squared plus pi. Sorry, not equals. That should be a plus. Radius of 6. And then L. What is L? Length? It's a little tricky because we've seen L before in other shapes, but L, when it comes to a cone, look at the picture and look where L is. L is actually called slant height. So this is the slant height, because note it's not the vertical height from the center of the circle to the top. It's not H, but it's the slanted height. So what is the slant height in this example? It's 10. So that is our L. Okay, we can plug this into our calculator either just like this, or you can plug in your formula and then tell your calculator that the radius is 6 and that the slant height is 10. And let's see what you get. 301.44 inches squared, or square inches. All right, now we're going to find the surface area of a square-based pyramid. So there is our pyramid, and we're finding the surface area. So I don't care about the volume formula. Now, let's just look at what this formula says real quick. 1/2 LP plus capital B. Whew, those are a lot of new letters compared to what we've been seeing. So L, like we said in the last one, L means the slant height. So look at the picture of the pyramid. You see how the slant height is on the side? It's not going from the center of the base to the top. It's going from the side to the top. So that's your slant height. That's your L. And capital B, remember we talked about this last class. Capital B is the area of the base. So we're going to have to find the area of the base. Note, this is a square-based pyramid, so we'll be using the formula for area of a square. So let's plug in what we know. 1/2 Slant height. Well, the slant height is on one of the triangular sides. So it's not going to come from these sixes. That's part of the base. Note this is a flat net of the figure. This is like if we took the pyramid and flattened it out, we broke it apart. So the slant height is the height of one of the triangular sides. So that'll be 9. That's our slant height. 9. P stands for perimeter of the base. So I noticed we didn't mention that before. P stands for perimeter of the base. So what is the perimeter of this base if it's a square with a side length of 6? Well, the perimeter of a square is just 4 times the side length, so 6. Then we need to find the area of the base. Area of a square is just side squared, or in this case, the side length is 6, so 6 squared. So when we plug that in, let's see what we get. Now I know it looks a little bit different, but here's how our work turned out. It had a perimeter of 4 times 6 or 24. It had an area of the base of 6 squared or 36. For a final answer, a surface area of 144 feet squared. I think the pyramids are probably the most challenging to me. So with that being said, let's try one more pyramid, just because this is a newer shape. You guys have never worked with pyramids before Math 8, so let's actually play around with it and get some more experience with it, so we're feeling confident. So I know we may have just seen the answer, but it's all good. We still need to know how to do it. So let's find the surface area of the square-based pyramid below. So we're using this formula. Volume doesn't matter. We need L, so that's the slant height. We need P, which is the perimeter of the base. So the perimeter of this square base. And then we need capital B, which is the area of the base, or the area of this square. So what is our slant height? What's the height of a triangular side? Well, it tells us this triangular side right here has a slant height of 6. So our L is 6. P is the perimeter of the base. Perimeter of a square is just 4 times the side length, which in this case is 5 meters. The area of the base is the area of a square, which is just the side squared. Let's check our work. So we got a final answer of 85 meters squared. All right, let's look at a good old rectangular prism. So we're talking about a box. We've got the answer right there, but let's see how we got it. Okay, Charlene is shipping a package to her aunt. The cardboard box is shown. What is the surface area of the box? There's our formula. I don't care about volume. I need to take this formula, and you know what I'm going to do? I'm just going to plug this directly into the calculator, and then I'm going to tell the calculator the length, the width, and the height. And I'm going to make my calculator do the work. I'm going to say that the length is 3, that the width is 1, and that the height is 1.5. So let's plug them in, see what we get. All right, we should have gotten 18 feet squared. Hopefully that wasn't too difficult. All right, I think this is our last one. So this is a word problem, but already we know what type of figure this is going to be. So we're going to have a cone, and we just need to know, are they looking for volume or surface area? George created a volcano for a science project. He wants to keep it safe from the rain. How much plastic will George need to cover the volcano? So covering means surface area. Round to the nearest whole number. And I'm actually going to change this to round to the nearest hundredth. We'll see why in a second. Okay, so there's our surface area formula. Surface area is pi r squared plus pi r L, where r stands for radius and L stands for slant height. And if you look at your formula sheet, look where L is. L is on the outside of the cone. It's not from the inside up, it's on the outside. So let's look at what they gave us. The radius of 12, so we have a radius of 12. And then they say that this height right here is 24. So have they given us the slant height? No, they've actually given us the vertical height, but we need to find the slant height, this side right here. This is what we're looking for. So this is a right triangle. You remember cases before we've seen in class where you have a right triangle and you've got parts of it, but you're missing one side of it. Do you remember what we used to find that? We used the Pythagorean theorem. So that's what we're going to use, the Pythagorean theorem. And this is on your formula sheet. So look on your formula sheet, you're going to see a right triangle that has A, B, and C. And it'll tell you the formula is a squared plus b squared equals c squared, where A and B are the legs or the sides that make the right angle. So in this case, 24 and 12. And C is the hypotenuse. It's the slanted side that's opposite of the right angle, which is what we're looking for. We're looking for C. So we're going to use the Pythagorean theorem to find it. 24 squared plus 12 squared, what do you get? We should get 720 equals C squared. We need to do the inverse of squared to get C by itself. So we take the square root and we'll get C equals what? So we're going to get C equals 26.83. So let's see how it turns out when we plug it in. So here's the work. When we did our Pythagorean theorem right here, we got C, or the slant height, is 26.83. Our radius was 12. And 24 is just the height of the cone. So in our surface area formula, we have pi r squared, or 3.1412 squared, plus pi times radius times the slant height. We plug those all in, we're going to get this value. So which of these numbers did we actually not even plug into the formula? Yeah, 24. We didn't even really need that. That was just going to help us use the Pythagorean theorem to find the missing side. So this is definitely a higher level question because it had you find a missing piece of the figure before you could actually even find the surface area. So it's okay if you didn't feel super confident with this. We'll see some more to practice it. So just to sum it up, to find the surface area of a 3D figure, make sure that you are using the appropriate formula, using the formula sheet. Find any missing values that you might need, and then apply the formula. Use your calculator, work carefully, make sure you're plugging in the correct numbers, and make sure that your answer is reasonable.